The probability distribution is a mathematical tool that allows us to understand how likely certain events are. For example, if we want to know how likely it is that the average person will live to be 100 years old, we could use the binomial distribution. This formula tells us that if an individual has two outcomes, e.g., being born or not, and each outcome has a probability of occurrence, then the probability of their being born is 1/2 asterisk 1/2 asterisk 1/2 equals 1/8 equals 12%. This means that if we were to ask someone who was born 100 years ago whether they expected to live another 100 years, they would have had a 12% chance of living another 100 years, assuming all other factors remained equal at the time of birth. In real life, the probability distribution of a random variable is the way that we can determine how likely it is that a particular outcome will occur. For example, if you have a dice and you roll it twice, what are the chances that you'll get a total of 7? The answer is simple, 16 out of 20. The probability distribution can be used to determine whether or not an event will happen in the future. For example, let's say you want to know if your friend will be able to pass her driving test on her next attempt. If she's never taken a road test before, then we can use our knowledge of how often people fail their road tests and predict that she will fail again this time around, and vice versa. I'm a math teacher, and I have a friend who's a chemist. We were talking one day, and he told me that they think that the probability distribution of molecules can be used to predict what kind of molecule will form when you put them together. I said, "Oh yeah? How do you do that?" He said, "Well, if we know that there are only two kinds of molecules in the universe, A and B, then we can use the distribution to figure out which ones will combine." "That sounds like a good idea," I said. "But how does it work?" He explained, "If there are twice as many A-type molecules as B-type molecules, then there will be twice as many A-types joining together with other A-types than B-types doing so. It's simple math." The probability distribution of a random variable is the way in which we can measure how likely it is that a given outcome will occur. It's important to understand that the probability distribution of a random variable doesn't just tell us what kind of outcomes are likely, but also how many of those outcomes there are. For example, let's say we have a coin flip. Heads or tails? If I flip the coin and get heads, then my probability distribution tells me that this outcome is 1/2. If I get tails instead, then my probability distribution tells me that this outcome is 1/2 plus 1/4 equals 3/4. But why does this matter? Well, imagine that I'm trying to decide whether or not to invest money in Google stocks because they've been going up recently. I could buy them now, or wait until they've dropped a little bit before buying more shares in them. If I buy now and they drop by 10%, then my investment will lose me 10% of its value. This might sound like a lot, but if you're talking about thousands of dollars worth of investments over time, it adds up fast. We've all heard of the bell curve, but what is it really? The bell curve is a mathematical model that describes the probability distribution of a set of data. It's used in many fields, including psychology, economics, and statistics. It can be used to describe how likely people are to do something, like commit a crime, or how likely they are to succeed at something, like getting into college. In this example, we'll use the bell curve to explain why some people get into college while others don't. When I was in middle school, I was working on a project about the probability distribution of different types of animals. I had this idea that I wanted to use my knowledge of math and probability to figure out what kind of animal would be most likely to live in each habitat. I got this idea from watching Animal Planet's Survivor, and thinking about how many different species were on the show and how many of them had never won the game. I thought maybe there was something about the way those animals were distributed that made them less likely to win than others. So I started looking at all kinds of data sets and using programming languages like Python and R, which helped me crunch numbers faster than ever before. After weeks of research into statistics, I finally cracked open my laptop one night after dinner and put together a program that let me explore what it might mean if you could predict whether or not an animal would survive based on its habitat type, e.g., desert, grassland. The results were shocking. There were actually 5 distinct types of animals that lived in each habitat type. And once we figured out what type, I was sitting in my math class, thinking about how to solve a problem. I had been working on it for a while, but I wasn't getting anywhere. Finally, I decided to take a break and do something else for a few minutes. I'm going to go get some coffee, I said to my friend, Name. Okay, she replied. Do you want me to answer any questions if they come up? No, I said. I think this will help me figure out the answer. I left the room, feeling confident that my solution would be revealed soon enough. As I walked down the hall toward the cafeteria, however, my mind began wandering away from its focus on mathematics and toward other topics. What people were doing outside of class. The weather. Whether or not it was raining yet. Whether or not there were any cute guys nearby who might want to chat with me after class ended. There weren't. A friend of mine was driving home from work when he saw a man who was clearly in distress. The man was standing on the side of the road, waving his arms and shouting at passing cars to help him. My friend stopped his car and got out to see what was going on. When he got closer, he could see that this man's car had broken down and that he was trying to get help from passing drivers. But here's the thing, there were no other cars around. And since this road was not a busy one, there were no pedestrians or bicyclists either, so no one else would stop to help him fix his car. My friend tried calling 911 on his cell phone but couldn't get an operator because it was too late in the day for call centers to be open. And anyway, they'd have told him it would take hours before anyone showed up. So instead of just sitting there helplessly while this poor guy waited for someone else to come along with a tow truck or whatever else might help him fix his vehicle. It's one of the most common questions in science. What is the probability distribution of an event? The probability distribution of an event is simply a way of communicating how likely it is that an event will happen. If you're looking at a card game and your opponent has 3 cards in their hand, what are the chances they'll draw a 4th card? Well, if you know that there are 4 possible outcomes, 2 cards could be hearts, 2 could be diamonds, then each possible outcome has a probability associated with it. And those probabilities can be added together to get the overall chance of drawing another card. And this applies to everything from flipping coins to predicting whether or not someone will get married. In the world of mathematics, a probability distribution is a way of describing how likely it is that an event will occur. In other words, it's a way of saying how many times something happens in a given amount of time. Let's say you're playing roulette and you bet on red every time. The odds of winning are 1 in 52, but if you play enough times, eventually you'll win. It doesn't matter whether or not your next spin is black or red, you're still going to win. This is because there are more reds than blacks at any given point in time, because there are only 32 colors. So if you play long enough and keep hitting reds, eventually one of them will come up. If we want to know how often this will happen, i.e., what probability, we can look at the distribution of outcomes for each spin and use those numbers as probabilities for each color. In the 1940s, a group of scientists was working on a problem that had been bothering them for years: how to model the probability distribution of a set of events. They had assumed that if you have one event, like, a person has brown eyes, then the probability of it happening is 1/2. But they didn't know how to prove this mathematically. So they came up with an experiment. They took 2 different sets of people and labeled them brown-eyed or blue-eyed, then asked them to look at each other's eyes and guess whether they were blue or brown. They found that people were more likely to guess correctly when their own eye color matched what they saw in others' eyes. But when it didn't match, people were less confident about their guesses. This led them to realize that there was something special about pairs of things that are alike but not identical. If 2 things are alike but not identical, then their difference is greater than or equal to 0. So we can say that 2 things are indistinguishable. A man named John was walking through the woods when he saw an old woman sitting under a tree. She was wearing a long, flowing gown and had her hair in a bun. She looked at him with big eyes and smiled. "Hello," said John. "Are you lost?" "No," she replied, "I'm just waiting for someone to find me." John felt bad for her and went back home to tell his friends about it. They agreed that they should go find this woman and bring her back to town with them so she wouldn't be alone anymore. They set out on their journey again, but before long they realized that they were being followed by 3 bears. The bears were much bigger than any of them, but they didn't seem dangerous, just hungry for food or something like that. So, after some discussion between them all, including their mothers, they decided that everyone would stay together until someone found the old woman again and brought her back home safely.